Pause the video and you try them out on your own. We'll go ahead and go through all of them, but I want to make sure that you guys actually have a chance and opportunity to pause and try these out. You're going to see this quite a bit as well, so just keep that in mind. Anytime that you see pause the video, try out the problem on your own, and then we can go through it together. All right, so looking at this one, we have lines AC. I can also say this is line AB or CA or CB, but I have line AC and line DE that intersect each other. So, how many lines are shown? Imagine that there are arrows on the diagram, so I already drew those in for you guys, so these are all arrows. So if we're looking for lines shown, then we, of course, have two lines. So we have two lines that are shown, line AC and line DE. So I can name those in multiple ways. So if you name that line AB, line AC, line CB, or line CA, those are all fine. So again, AB, DB also works for one. I can name it BC, line BC, line BE, line DE, or line AC. So all these work. I tried to color coordinate a little bit to make sure that you guys can kind of see where these names are coming from and how they relate to one another. Where do lines AC and line DE intersect each other? So where do they meet or where do they overlap? So if we look at AC and DE, they overlap at point B, right here. Next up, where does ray AC, so if I look at ray AC, so it starts at A, go towards C in an infinite direction, and line BC, where do they intersect? So again, if we're thinking about intersections, we're thinking about where they cross or overlap. So I'm going from A to C, so for these I like to kind of draw on it. So I'm going from A to C, and then I also have line BC. So BC is the entire line going both directions. Well, they overlap at ray BC. So ray BC and AC overlap at BC. And then lastly, what is the union of BA? So this is ray BA and ray BD. So I'm looking for the union. Union is what we create. So what do rays BA and BD create? Well, if it's two rays that are being unioned, then it's going to create an angle for us, and that angle is ABD. So ABD. Now, are there other ways to name this? Yes, I can name it angle DBA as well. Could I just name it angle B? Well, no. The reason I cannot name this angle B is because I can say that this is angle B, right? Because it has point B as its endpoint. I can also say that this is angle B. I can say that this is angle B or this is angle B. So I need to be very specific when we're dealing with multiple lines and rays and things of that nature. So be very careful that we don't name this angle B, but I can name it angle ABD. I can name it angle DBA, so on. Just be wary of that, though. This is not called angle B, even though angle B is our endpoint, and that is why it's still in the middle. All right. Go ahead and pause the video here, try out this problem, and then unpause it to go through the explanations. All right. So, again, we need to be careful of what these symbols mean here in the middle. So again, if it's upside down, if it's an upside down U, that means intersection. If it's a normal U, that means union. So for this first one, we have angle EAC. So angle EAC, and go ahead and outline that. That's what I like to do for these ones, because if I outline it, then it's much easier for me to see. So I have angle EAC intersects segment AC. Well, where do those intersect each other at? Where do they overlap? Well, they overlap at line segment AC. All right, next one. We're finding the union. So union is what they create of EC. Oops, sorry about that. Of EC and EA. So segments EC and EA. Well, if they're unioned, it's what they create. So what do they create? Well, they create an angle for us. They create angle AEC. So AEC is this angle right here. Or I can also name this angle CEA. The main thing is that our endpoint of both of those is in the center here. It's in the center letter. All right, next up, an intersection. So an intersection of segment BE and intersection of FD. So again, these are segments, so be careful of that. So we have, let me go ahead and do blue here. We have BE right there, and then we have FD down here. Now looking at this, we're talking about segments, remember. Will segments go on forever? No. Segments have a finite beginning and end, so they won't go on forever. So therefore, do these intersect each other at all? Well, no. So if they don't intersect each other at all, again, we're dealing with FD here, just that segment, and segment BE here. If they don't intersect each other at all, then our answer is no solution. So again, if it's not intersecting, they're not unionizing, they're not creating anything or not overlapping each other anywhere, it's okay to have a no solution answer. So just keep that in mind. It makes sense. They won't touch, so therefore they won't intersect, so therefore there's no solution. All right, our final one. Our final one is AB intersection BC. So I have segment AB intersects with segment BC. So if I have these two and it's an intersection, where do those cross? Where do they intersect? Well, they intersect each other at point B. So that should be our answer, point B. Again, we can see that AB and BC intersect at point B. All right, and again, I just want to leave this here for you guys. The U is a union, what they create. Meanwhile, the upside down U, is an intersection. Where they cross. So make sure that you guys know unions and intersections, very important. You're going to see it quite a bit. Oftentimes students start, not caring too much about these if we don't see them for a couple days. So, and then it shows up on, say, a formative or a test, and people get lost for a second. So make sure that you know what both of these symbols mean and how to find them as well. Very important for you guys to be able to do that, especially given a diagram such as this. All right, let's continue on. Go ahead and take a second, pause the video, and when you get back, I'll go ahead and go through the explanation. All right, so here we have problem 2. We have, as we can see, a ray. It has an endpoint at A, and it goes in the direction of C forever. So I can say this is ray AB, ray AC. Both of those work. Can I name this as ray BC? Well, not necessarily, because I always got to start with our endpoint in mind. And our endpoint is point A. It's not point B here. Point B is just a point that is on our ray. So name the ray that has endpoint A and goes in the direction of C. So we have two different names here. If I start at A, because again it's a ray, I start at A, so A is going to go first, and then I go in the direction of C. So I can have that as ray AC. I can also name this as ray AB, because again we're starting at point A, and if I go in the direction of C, well, since B is on the line and it's between A and C, it means that I can also name this as ray AB, because again rays go on forever in one direction, so it's eventually going to cross through C as well. Name the segment joining A and B. So a segment joining A and B, I can name that as segment AB. And then I can put the dots here if I'd like. You don't necessarily need to show the dots, but I cannot see an arrow. If we're going on a test or something like this, and it's asking for a segment and I see an arrow at one end or both ends, you're going to get it marked off. Segments need to have dots on the ends. Rays must have one arrow. Lines must have 2 arrows. So just be careful when you're doing this notation here that you're good to go, that you're talking about which figure you're actually talking about. All right, and again, here's our answers here. We got AC, start with the endpoint in name of ray, and this also works as AB, and then of course we have segment AB or segment BA. Either way works for segments. It doesn't matter which letter comes first. However, in rays, it is very important that our endpoint starts it. All right, go ahead and pause the video again and try out problem 3. When you're done trying out problem 3, go ahead and unpause the video and we'll continue. All right, so for problem 3, we're going to draw a diagram in which the intersection of ray AB with ray CA is line segment AC. So this one's a little bit confusing, but I start off by drawing ray AB. So here's AB. I'll go ahead and put B right over here. And when the intersection occurs with CA, then we have AC as the result. So I'm going to go ahead and draw CA. Now I know that A is going to be on the same line that we just drew on ray AB. So if I draw CA, if I draw C in between A and B, if I draw C here, and it goes in the direction of A, because again it's a ray, then let's see where our intersection is. So if we're dealing with the intersection, I know that's where they cross, where they intersect. Well, where these two rays intersect is between A and C. So therefore, this diagram works. Because if I have AB, ray AB, and ray CA, when they intersect, it creates segment AC for us. So that's where this diagram came through. All right, we got another one. Make sure that you guys are trying these out because, again, a little bit difficult, but as you practice them more and more and you think about what we're dealing with, the better off you'll be. All right. And again, there it is. So go ahead and pause the video for this next one. We're going to draw a diagram in which triangle ABC intersects line segment, or sorry, this is a ray. So this is ray DE at point F. So go ahead and draw this out. And when you're finished drawing it out and trying it on your own, come on back and we'll go through it. All right, so for this one, I'm going to go ahead and start off with triangle ABC. So I have triangle ABC here. And then I have a ray DE. So looking at this, they're going to intersect each other. So they're going to cross each other at some point. And I know that I don't have D or E on my actual triangle so far. I just have A, B, and C. There's no DE. So I'm going to go ahead and draw a ray, DE. So I'm going to just say, okay, I'm going to start at D on the inside. And then E is going to be on the outside here. And in between those, we're going to have point F, where they intersect each other. Well, if I have two things intersecting each other, it's where they cross. So point F should be right on our triangle there. So if I look at this, I have triangle ABC intersects ray DE at point F. And there it is. All right. Go ahead and pause the video one more time. Draw a diagram in which the intersection of angle AEF and angle DPC is segment ED. All right. So looking at this, we have angle AEF. So let's go ahead and draw that out. AEF. So I have A, E is our endpoint. And then we have F right over here. Now, when we intersect these, we should have ray ED as our intersection. So if I think about that, I want ED as our intersection. So I know that our next one is angle DPC. So if that's the case, P is our endpoint. So I'm going to put P in between E and F. Now, when they intersect, we're going to create ray ED. So D must be over here. D must be over here because when these two angles intersect, they're going to create a ray for us. And then, of course, I can draw C in a couple different ways. I can draw it up. I can draw it down. Totally up to you. I'm going to go ahead and draw mine down. So I have this purple angle and this red angle. So now if I look at this, where they intersect each other, where they cross each other is, so in which the intersection of AEF and DPC is ray ED. So where they cross each other is this ray right here. And again, I can draw it this way. This way may make a little bit more sense as well. If I have angle AEF and angle DPC, then where these two angles intersect each other is ray ED. And again, it continues on forever because they're sharing this common ray here, this common purple ray that I'm filling in. So keep that in mind. I'd probably stick to this one a little bit more so because it is a better example of seeing that, hey, they cross each other and this ray continues forever and ever for both these angles. All right, go ahead and pause the video once again. I believe we're getting close to the end here. And try this problem out. All right, so it states, what percentage of the triangles in the diagram have CT, segment CT, as a side? So first I need to count up all the triangles in my diagram. So let's see, I have 1, 2, 3, 4. I have this larger one here. Be 5. And then I have one on the other side, that's 6. I have 7. And then I have 8. So I have 8 total triangles here. I want to know which percentage have CT as a side. So if I look at this triangle has CT as a side, as does this triangle. There's 2. Here's a third triangle that has it. So we have 3. 3 out of 8, which would be 37.5%. If I do 3 divided by 8 on the calculator, I get 0.375. I move my decimal place 2 places to the right, giving us 37.5%. What percentage have AC as a side? So if I look at this, AC is right here, and the only triangle that has AC as a side is this triangle. And I guess I could also say this triangle down here would as well. So this should actually be 2 out of 8. So this shouldn't be 1 out of 8, this should be 2 out of 8. 2 out of 8 is the same as 1/4, which is 25%. So our answer for this one is 25% because AC is shared by this triangle here as well as this triangle here. All right, next up, find the union of segment EC, CD, and DE. So we're finding the union, we're creating something out of 3 segments. Think back. What is the union of 3 segments? Well, by definition, that's a triangle. So creating a triangle here, we have triangle ECD. So if I look at this, we have EC, union CD, union DE. It creates a nice triangle for us, triangle ECD. Could I name this other ways? Yes. I can name this triangle CDE. I can name it triangle CED. I can name it triangle DCE. Tons of different ways as long as I have these 3 letters put together. All right. And then we have the intersection of ray AC. So let me go ahead and draw ray AC here. So of ray AC and ray EC. So we want to know where these two intersect each other at, where they cross over each other. And if I look at this, well, AC goes all the way through, right? AC goes from A all the way through C and forever on in that direction. EC starts further up than AC does, but continues in that direction forever as well. So our intersection is actually ray EC as well. So again, triangle ECD, name this in any way that you'd like, and then we have EC. Very important that we start with E in our naming because that is our endpoint, and then in the direction it goes, which is towards C. All right, we have now finished Unit 1.1. Again, our learning target was I can interpret a diagram involving points, segments, lines, rays, and angles. This is something that you need to know for the test. Hopefully you guys feel better about doing that. We saw many diagrams today, some that you guys created, some that I gave to you guys, and they all involved points, segments, lines, rays, and angles. We learned more about our vocabulary and terminology such as unions and intersections as well. Very important that you guys know those as well. And of course, if you guys have any questions, make sure that you add those to discussion post number 2. That is all up for you guys, ready to go. As long as you ask questions in there or come into office hours, you guys will be good to go. After today's lesson, you guys should feel more comfortable with that terminology, and you should be able to interpret these terms from diagrams, create diagrams using these terms, or be able to write these in any way that you need to write them, including all those angle names or all of the rays and making sure that it's labeled all properly. If you guys can do all this, then you should be ready for 1.1 on the test. So again, make sure that you guys are getting that vocab in the student resources. It's the one that says must read. So if you see something like this, must read inside Schoology, look into that. That has flashcards for you guys, that has additional videos for you guys to watch if you need it. It has many things that I hope that you guys look into and that will help you out in this course as well. But make sure that you know this vocab. If you don't know the vocab, this course will be difficult. All right, your assignments that are due this Friday at 11:59 p.m. So again, I'm going to have assignments due, especially while we're online. They're going to be due every Friday. Here's all the assignments that you guys have to do. Most of them are already inside the folder that you're looking at. So the 1.1 homework, which is already up for you guys. The 1.2 homework, which is in the 1.2, which we'll get to tomorrow, as well as the 1.2 worksheet. So you guys will need to do both of these as well. We haven't covered these quite yet, so if you want to get started on those, you can, but if you want to hold up for a day, that's okay as well. The Honors Geometry Summer Packet, that is due this Friday. Directions for that are on Schoology as well for you guys to check out. Make sure that you guys get that finished up. Syllabus acknowledgement. I need you guys to make sure that you read through the syllabus, make sure that your parents read through the syllabus, sign off on it. There is a turn-in on Schoology, just saying that you read through it and accept all the terms for it. And then lastly, you have a weekly formative assessment that needs to be done. This is so that I can see where you guys stand, and it'll also make sure that you guys are good to go. And it lets me check to see if I need to recover anything for you guys. So just please make sure that these are all finished for you guys. If you guys have any questions on anything, again, ask in discussion post number 2, or come talk to me in office hours. I'll be happy to help you guys however I can. Other than that, thank you guys for watching. I hope that you have a great rest of your day. And if you need anything, please let me know.